So we're going to start this by recalling the distributive property, right? The distributive property, something we used a lot lately, says that you can distribute multiplication over addition and subtraction, and so A multiplied by B plus C is AB plus AC. Because this is an equation, what it means is that if it works left to right, it also works right to left. If you have an expression AB plus AC, in other words, where every term has the same variable part, right, the same factor, right, the same factor, or what we would call a common factor, you can undistribute it, right, into A multiplied by B plus C. This reverse of the distributive property is what we call factoring out the common factor, or ideally the greatest common factor. Let's take a look at how this works in several examples. So example 1, we have 4x minus 14. And what we notice is that when we look at 4 and 14, both of those numbers are divisible by 2. That's another way of saying that they have a common factor of 2. And so we can unmultiply the 2, or undistribute that multiplication of 2 by 2 from each term. And since we're undoing a multiplication by 2, another way of saying it is we're dividing by 2. So 4x divided by 2 is 2x, and 14 divided by 2 is 7. So we have 2 times 2x minus 7. Again, to kind of restate what we did, we divided each of these 14 and 4x by 2 to get the 2x minus 7. And since we divided, we put the 2 out front, that multiplication. Now, when you look at your answer, you may ask, well, did I do this correctly? How can I check? And there are really 3 questions that you should ask yourself, right? First thing, you were asked to factor. Did you factor? Right? Did I factor? That's a question you can ask. So it's very easy to answer. Just look at your answer and you see, oh, it's a multiplication problem. So yeah, I factored. I rewrote an expression as a multiplication problem. The second question you should ask yourself is, did I factor correctly? Seems like a useful thing to note. And correctly basically means that if you were to do the multiplication, you should get your original expression. So if I multiply 2 by 2x, I get 4x. And if I multiply 2 by 7, I get 14. 4x minus 14 looks like we factored correctly. And the third question you should ask yourself is, did I factor completely? And what we mean by that is, can more be factored out? Well, if you look at what's inside of the parentheses, 2x minus 7, there are no common factors here, so there's nothing more for you to factor out. You did factor completely. So that's kind of a checklist of things you may want to quickly ask yourself before moving on to the next problem. Is this factored? Is this factored correctly? Is this factored completely? Let's take a look at the next example. 5x plus 8xy. When we look at the numbers, the 5 and the 8, we don't really see any common factors, right? We don't really care about 1 because the dividing by 1 doesn't change anything. So those aren't really interesting, but there is a common factor of x. There is a common variable, right? X. And so that's the thing that we can factor out. And when we divide each term by x, right, if we divide 5x by x, we're left with 5. And if we divide 8xy by x, x is canceled and we're just left with 8y. And so our answer is x times 5 plus 8y. Again, it's not difficult to check if this is correct, right? We obviously factored because it's a multiplication problem. If I distribute, I get 5x plus 8xy, so which is what we started with. So it looks like we did it correctly. And there are no common factors between the 5 and the 8y, right? So it looks like we also did it completely. So this is exactly right. Let's do one more example. 12mn minus 12m. When we look at 27 and 12, 27 and 12 are both divisible by 3. So 3 is definitely something that we can factor out. Also, there is a common variable factor of m. So your full greatest common factor is 3m. Now, when you divide 27mn by 3m, the m's cancel. 27 divided by 3 is 9, so that's just 9n minus, if we divide 12m by 3m, m's cancel. 12 divided by 3 is 4. And so our answer is 3m times 9n minus 4. Now, obviously we did this correctly because when we multiply, we see 3 times m times 9n is 27mn, and 3 times 4 is 12, so minus 12m. I said mn. So this definitely looks like we did everything correctly, right? It's multiplication, it multiplies correctly. 9n and 4 don't have common factors, so we did it completely. Everything is good. Common mistakes that some people make here is when you start with the original expression, 27mn minus 12m, some people may only notice that there's a common factor of m. Factor it out, leaving 27n minus 12. The problem is definitely factored because it's multiplication. You definitely factored correctly because if you multiply m into each term, you do get 27mn minus 12n m. But the problem is it's not factored completely because 27 and 12 are both divisible by 3. There's another common factor that you can factor out from there. So this would not be exactly right. This is not factored completely. A similar thing could happen if when you start with this expression, you factor out the 3, but forget that there's also a common factor of m. Then 27 divided by 3 is 9mn, and 12 divided by 3 is 4. You can see you definitely factored because 3 is being multiplied by this expression, 9mn minus 4m. You definitely factored correctly because 3 times 9 is 27mn, and 3 times 4 is 12m. But you didn't factor completely because in your parentheses, there's also a common factor of m, so you could go further. So it's very important when you finish the problem to give it a quick check to see, did you factor Is it correct? And did you factor completely?